If you've ever wondered what a fold change is referring to when it's used in medical research context, in the context of data analysis, then this video is for you. A fold change has nothing to do with folding. Yeah, I know, surprising. Fold change is simply a ratio. It measures the number of times that something has changed. For example, if you are comparing an experimental group and a control group, you will divide the results for the experimental group by that of the control group. If you're measuring a signal over time, you may want to look at the signal in reference to the very first time point, or you may want to look at the signal from the latest time point to the one just before it, the previous time point. As an example, let's say the intensity that I got for protein expression for one time point was this value. Then I can look at, and this was the experimental group, then I can look at the control group, and the control group has this value. So to look at, I may want to see what's the fold change, what's the ratio here. So I can just go ahead and do the experimental group and divide that by the control group. Sometimes it may be more meaningful to look at the percentage difference. So actually the difference is what you are concentrating on. So in this case, you will take away the value, the new value, you take away the initial value and then divide it by the initial value. And often it's also meaningful to present it as a percentage. So you multiply it per 100 and that just makes it easier to get meaning. Now, if, for example, we're looking at an antibody response following infection, we may easily report it as a fold change. So we would get the original expression, the original quantity, which we may have measured via Western blot or an ELISA, enzyme-linked immunosorbent assay. So then we can just simply divide into the original amount that we got. It's just a ratio of the results. They easily express that to make it meaningful at a glance as a percentage, and that's just by multiplying it by 100. How about day 3? We will simply just divide that value into the original. So we will divide the signal at the new time point or the day by the signal at the beginning or at the initial infection. So what we see that we have a 9-fold change. It's 9.8, so almost a 10-fold change from the day 1 post-infection to the second. We have almost a 10-fold change. Then by day 3, between day 3 and the day 1, there's a 1.74-fold change, and so on and so forth for the remainder of the day. And then you can just look at that in terms, present that as percentage just to make it easier for your audience, for the person looking at your data to just immediately get a sense of what that means. So if we just multiply that by 100, we may also want to present the data in terms of the difference in the data rather than the absolute fold change. And in that case, it's our new value minus the original divided by the original. Present that as percentage just to make it easier for your audience. When I leave the number just as the difference without multiplying by 100, you can see, 0.22. 0.22 is a small value. It's not immediately clear to someone what, they don't get a good sense of the number because we don't normally deal with that kind of scale. So just by multiplying by 100, we'll get a sense, it will be like 22%. And yeah, we're comfortable with that. So it's good to scale it to a percentage. If we want the rest of the cells to be calculated without us going through this process of doing it ourselves, we simply constrain the cell by just placing a $sign in front of it. So we place a $sign in front of the row as well as the column, and then by dragging it down, Excel knows to do exactly the same thing for the remainder of the cells. And then we can go ahead and plot it. And plotting in Excel is super easy. You just have to select the two columns that you want to plot and go to insert, and you can select the type of chart that you want. So for this kind of time series or related data, it's best to use a line graph or a scatter graph. We can use a line graph in this case because it is related, and we can go ahead and it will automatically have a line that tracks it for us. And just by making some simple adjustments, we can make the graph look really attractive. Now, I will not go into too much detail because this is just on fold change and on the percentage difference calculations. If you would like to see the graphs done in Excel, then please let me know. But I will leave it here for now. And if you are interested in joining the study group, go ahead and hit the subscribe button, and I will catch you in the next video. God bless you and take care.